All right then, now let's talk about antilogs. So we have seen that logarithms are nothing but the inverse functions of exponential functions. So we can, let me write it over here. So if we just invert log functions, let me do it again. If we just invert exponential functions, we get logarithmic functions. So which means when I want to talk about antilogs now, so antilog, as the term suggests, they are going to be inverse of logarithms. So I should get exponential functions back. Because if this is function f, then the corresponding logarithm is function f inverse. And if we want to talk about inverse of f inverse, that is just the parent function f. So this antilog function is nothing but exponential functions. But when I'm saying taking antilogs, that means I'm just considering, I'm talking about the procedure that that needs to be applied when we want to remove log per se. So we'll see that in this problem. So before that, let me talk in terms of notation a little bit. So let's say I have this thing log of x base b, that is y. This is the equation I'm interested in. Then we understand we can immediately convert it into exponential format, wherein x becomes the output and y becomes the input. So this comes as x is equal to b power y. So this comes from the definition. Writing this or this, they are exactly same things. But so this is good. This is what we are talking about now. But the thing is, when we are working within problems, we don't want to always work like this. We'll just, instead of going through this operation, we'll just say we are applying antilogs. And what do I mean by that? So instead of doing this, I will start with equation log x base b is y. Then the next step that I will write is I will apply base b both the sides. So I will have b raised to power log x base b this side and b raised to power y this side. So I must mark clearly here. So I have applied, I've not divided by b, I've used it as a base. Because if p is q, then b raised to power p should be equal to b raised to power q, because b is a valid base. So, and then I will invoke the property that we have already talked about. So we know that b raised to power log x base b, that is just x, because whenever these bases they match, they cancel out each other. Logarithm and exponential function, they cancel out each other. So we get x back. So if I use this property here, I can simplify this side and I get x, and that side is b raised to y, which is necessarily this thing which we were earlier writing over here. So this procedure of applying base both the sides is called taking antilogs. So antilog just removes the logarithm, and by antilog we just mean exponential function. So this has to happen naturally because they are inverse functions. So this is the algorithm that we perform whenever we want to remove logarithm, and when we want to apply logarithm, we just put log both the sides. So here in this case, let's come back to this question now. So I'm given this equation and I have to pull out what is x, the value of x we need. So let's pull this thing downstairs. And so first thing we notice here is that I have x sitting over here, and if I want to reach this point, then I have to remove this log and then this log. So because this is the outer log, so that we need to remove this thing first. So because this is base 3, so we'll just apply base 3 both the sides. So next step I'm going to write is 3 raised to power this whole thing, the left hand side, that should be equal to 3 raised to power 2. And this side, these things, they cancel out because under the same property that we have marked over here. So what do I get? So these things, they cancel out. So I'm left with 5 plus 4 log x minus 1 base 3. And this side we get 9. And that gives me, we can take 5 the other side and then divide it by 4, which leaves us with 1. And now I need to remove this logarithm, which is again of base 3. So again, I will apply this base. So I will apply base 3, both the sides. So I get this. Now again, since the bases match, so these terms will cancel out. I get x minus y, which is 3. So x is 4. So that should be the value of x in this equation. So we have talked about the procedure here. So this is the technique wherein we are taking antilog. So taking antilog just means applying these bases both the sides. And we have used this thing twice in this question. First to remove this outer log and then to remove this inner log. Both were of base 3. So we just applied base 3 twice. So we isolated the corresponding logarithms and we just applied the base, and then once these things they match, they cancel out, and we got rid of these logarithms. Right, so I hope this procedure of taking antilogs now makes sense. We'll be using it frequently in our further problems. Right, so we are finished at this point. Bye-bye.